We are looking at section 8.2. Section 8.2. Yes, we are recording. Colin, in your own seat. And that was recorded for posterity. Okay, so we're looking at section 8.2, trigonometric ratios. The objectives in this section are to find the sine, the cosine, and the tangent of an acute angle, and to use trig ratios to find side lengths in right triangles, and to solve real-world problems. So who uses this stuff? Contractors use trig ratios to build ramps that meet legal requirements. I thought that was kind of an interesting example that they showed. According to the Americans with Disabilities Act, the maximum slope allowed for a wheelchair ramp is 1/12, which is about 4.8 degrees. So properties of right triangles can help builders construct ramps that meet this requirement. So just to remind you, here, take a look at these three triangles. By the AA similarity postulate, a right triangle with a given acute angle is similar to every other right triangle with that same acute angle. So if you notice, these three right triangles all have an acute angle of 32 degrees. They're all different sizes, but they're all similar to each other by AA similarity theorem, right, from last chapter, okay? And that means that the triangle ABC is similar to triangle DEF, is similar to triangle XYZ, and the ratio of, we're taking BC over AC. That means that the ratio of BC over AC is to, by the way, BC, would you call that the adjacent leg to the 32 degrees or the opposite leg? All right, opposite leg. And what about AC? Is that the adjacent leg or is that the hypotenuse? All right, so we're really saying the opposite leg over the hypotenuse in this triangle is the same as EF over DF. EF, is that the adjacent leg or the opposite leg to this 32-degree angle? Opposite. And DF is the, all right, so we still have opposite leg over hypotenuse. And what about over here with YZ over XZ in this picture? YZ is the opposite and XZ is the hypotenuse. So if we take the opposite leg over the hypotenuse in all three of these, we're going to get the exact same answer. All those are proportional. So these are called trig ratios. A trigonometric ratio is a ratio of two sides of a right triangle. So here is our definition of trig ratios. You don't need to write down all of this, but I do want you to understand that the sine of an angle is the ratio of the length of the leg opposite the angle to the length of the hypotenuse. This is on your tool belt, correct? All right. So the sine of angle A is the opposite over the hypotenuse. That's what we were just working on. So all of these ratios here, BC over AC, EF over DF, YZ over XZ, those are all the opposite leg over the hypotenuse, and so those would all be the sine of, in this case, 32 degrees, sine of the angle. The cosine of an angle is the ratio of the length of the leg adjacent to the angle to the length of the hypotenuse. So cosine is the adjacent over the hypotenuse. The tangent of an angle is the ratio of the length of the leg opposite the angle to the length of the leg adjacent to the angle. So opposite over adjacent. And so there is a handy mnemonic device to help us remember this. Yeah, SOHCAHTOA. So SOHCAHTOA is a way of remembering all of these words that you see here in this table. Because the SOH, if we take this part first, that stands for the sine of an angle is equal to the opposite over the hypotenuse. Sine is the opposite over the hypotenuse, right? And then if we take a look at CAH, that would be the cosine of an angle is equal to the adjacent leg over the hypotenuse. And lastly, TOA stands for the tangent of an angle is equal to the opposite leg over the adjacent leg. All right, so SOHCAHTOA, if you remember how to spell it right, can be a nice mnemonic device for you to remember the trig ratios. All right, so let's take a look at how this works with an example. Interesting. Not the best. All right, there we go. Okay, so write each trig ratio as a fraction and as a decimal rounded to the nearest hundredth. So, for example, if I want you to say the sine of J, for instance, the sine of angle J. The sine of angle J, what's our formula for sine? All right, opposite leg over hypotenuse. So in that case, you got to focus on where angle J is. Which side is opposite angle J? The 11, the 61, or the 60? Emily? The 60 is the opposite leg. And Emily, what's the hypotenuse? 61. So the sine of angle J should be 60 over 61, and we could get a decimal for that with our calculator. Do you agree? That's 0.98. All right, what about the cosine of angle J? What's our formula for the cosine of an angle? Mackenzie? So the formula is adjacent over hypotenuse. So what's the adjacent leg to angle J? 11. And the hypotenuse is 61. All right. Now I want you to remember this day, and I want you to remember SOHCAHTOA when you are doing, when you are taking an ACT test. I guarantee you that there will be a SOHCAHTOA problem on your ACT test. Does that make sense? So this stuff you will see. Okay, so 11 over 61, and we could get a decimal for that. What about the tangent of the other angle? What about the tangent of angle K over here? If we want the tangent of angle K, what's our formula for tangent, Lauren? All right, opposite leg over adjacent leg. And so what would be the opposite leg from angle K? 11. And what's the adjacent leg to angle K? Do people agree with that? 11 over 60? All right, and that's about 0.18. Questions on this? Okay, then for my example 2 here, all right, so for this example here, use a special right triangle to write cosine of 30 degrees as a fraction. So I want to remind you, first of all, if we have a right triangle and we have one angle that's 30 degrees and one angle that's 60 degrees along with our right angle. This was one of our special right triangles that we studied back in chapter 6, right? Special right triangles. Do you remember, excuse me, do you remember the relationship between the side lengths in a 30, 60, 90 triangle? Okay, the shortest leg is the leg across from the 30-degree angle. So if I call that S, what's the hypotenuse length going to be?
Isn't that S rad 3? Or no, S squared on the other one.
Well, S rad 3 would be this one,
Yeah.
but not S squared. It's double. Yeah, 2S would be this length. Okay, so if that's the case, what would be the cosine of this angle? Cosine of 30 degrees. What's our formula for cosine? Adjacent over hypotenuse. So what's the adjacent length? Again, we're using S's now. Aaron, what's the adjacent leg. This is adjacent over hypotenuse. So what's the adjacent leg? 2s, do people agree?
No.
Well, 2s is across from the right angle. So that makes this the hypotenuse. So which is the adjacent? So s rad 3 over, what's our hypotenuse? 2s. And we notice here, I hope you notice, that the s's could divide out. True? So we get square root of 3 over 2. So the cosine of 30 degrees is equal to square root of 3 over 2. No matter what size triangle, right? Draw a little 30, 60, 90, draw a big 30, 60, 90. The cosine of the 30-degree angle is always going to be square root of 3 over 2. All right, that's always the ratio of the adjacent leg to the hypotenuse. All right. Questions on this? Okay. So in this, is that a little bit small? Okay. All right, I don't want to give anything away. So you can use, the reason, let me just say this, the reason that you were asked to get a scientific calculator for this class, one of the reasons, is for this lesson today, because you will need to be able to find sine, cosine, and tangent on your calculator. So can you locate your sine, cosine, and tangent buttons on your calculator? Okay, so let's do a little check with this. If you all find the tangent button, can you do tangent of 11 degrees on your calculator? What'd you get? 0.19. Does everyone have 0.19? Anyone have something other than 0.19? Please ask, because if you don't get 0.19, it doesn't mean you're doing something wrong. It means your calculator is set up in a different mode than degrees. It means it's figuring out like the tangent of 11 radians, for example. Pardon me? Yeah.
Just like that.
Yeah. No, not. Oh, you did tangent inverse. You did tangent inverse. You just want tangent of 11. Enter. No, that's not what you want. What is that? Okay. You know, you're in like radian mode. So.
Should I go in different one?
Okay. Let me come back. Work with you on that one. Okay. Everybody else, can you please find sine of 62 degrees and cosine of 30, and see if you agree with these numbers? 0.88, 0.87. Are we good? Okay, we are looking at this next example. Thank you, I do need that. Take a look at this example. Are we still frozen? Okay, for this next example. Yes? There we go. Okay. Find each length round to the nearest hundredth. So if we're trying to find the length of segment BC, that's this length right here. Okay, we see that we have 10.2 feet here, and what else do we know? And that we know angle B is 15 degrees. So we're trying to find BC. Is BC the adjacent leg, the opposite leg, or the hypotenuse to angle 15? All right, so we're trying to find the adjacent leg. I'm going to call it X for right now. All right, and we're given which side? Is this the opposite or the hypotenuse? Opposite. So we know the opposite, and we're trying to find the adjacent. So which trig function, sine, cosine, or tangent, deals with opposite and adjacent? Tangent. So for this problem, problem A here, we're going to want to say the tangent of 15 degrees is equal to the opposite over the adjacent. What's the opposite leg? 10.2. What's the adjacent leg? X. And this is what we're trying to solve this equation for X. So calculators, please. Can you all agree on what tangent of 15 degrees is? Give me a decimal for that. 0.267, something like that, equals 10.2 over X. Think of this as 0.267 over 1, if you will. And can you cross multiply and solve for X? You with me? So if I cross multiply, dividing both sides by 0.267 now, I'm getting x equaling what? 38.2. And what do I have here? 38.07. That's fine, close enough. They were maybe using a more exact answer than 0.267 for the tangent of 15 degrees, right? They might have been taking it to 4 decimal places or 5 decimal places. Close enough. All right, what about in this next sketch? We're trying to find segment QR. Is segment QR the adjacent leg to this 63-degree angle, the opposite leg, or the hypotenuse? Opposite leg. So this is the opposite leg. I'm going to call it Y. All right. And we are given which segment? We're given this RP is 12.9. Is that the adjacent leg or the hypotenuse? So which trig function involves opposite, which is Y, and hypotenuse, which is the 12.9? Sine. So we're going to use, for this one, we're going to say the sine of 63 degrees is equal to what over what? What am I writing for my equation? Amanda. Just hang on a second. Let's see. Sine is opposite over hypotenuse. So what's the opposite side? What's the opposite side of the 63-degree angle? Y over, what's the hypotenuse? 12.9. So that means I'm really trying to solve sine of 63 degrees equaling y over 12.9. Calculators, what's sine of 63 degrees? 0.89? 0.891? 0.891 equals y over 12.9. So what's y going to equal? That's not what I wanted to do.
11.49.
Do people agree with that? 11.49. In this case, I guess it's centimeters. Yes? And yeah, that's what I have here, 11.49 centimeters. All right, let's try one more of these. Let's try this one. In this picture, we're trying to find the length of segment. Oh, that's not what I wanted to happen. We're trying to find the length of segment FD. That's this segment right here. Is that the adjacent leg to the 39-degree angle, the opposite leg, or the hypotenuse? All right, so we are trying to find the hypotenuse. I'm going to call it Z in this case. Doesn't matter. Call it X, call it whatever you want. And we're given that this side, FE, is 20. Is that the adjacent leg, the opposite leg? Adjacent. So which trig function involves the adjacent and the hypotenuse? So we want to say cosine of what equals what over what? Can you fill in the blanks? Megan. So cosine of an angle is equal to, you're saying it's equal to the adjacent over the hypotenuse from SOHCAHTOA, right? And so you're saying cosine of 39 degrees is going to be equal to what over what? Do people agree with that? All right, what is the cosine of 39 degrees, calculators? 0.777 equals 20 over Z. True? Again, I would encourage you to think of this 0.777 over 1 and cross multiply to solve for Z. So what do we get? 0.777 Z equals 20, and so Z turns out to equal what? Sarah?
25.7.
What is it? 25?
25.
So Z equals 25.74. Do people agree with that? Does my book agree with that? 25.74. Are we okay with this? All right. Yes, in this case it was meters. Okay, so we're looking at this last example. A contractor is building a wheelchair ramp for a doorway that is 1.2 feet above the ground. To meet the ADA, Americans with Disabilities Act guidelines, the ramp will make an angle of 4.8 degrees with the ground. To the nearest hundredth of a foot, what is the horizontal distance covered by the ramp? So if you're catching on to what we're doing, we've got to make a ramp. Up to a doorway, right? And we know that it's 1.2 feet here, correct? You with me? And we're trying to find this horizontal distance, I'll call it x. Like, how far out should we start building the ramp so that it will be no more than, or exactly, 4.8 degrees right here? Agreed? So, how would you write an equation to set this up? Colin?
You want to do cosine for cosine of 4.8 degrees. What? Oh, no. Yeah. Tangent of 4.8.
Why'd you switch from cosine to tangent? And don't say because Lauren told you.
Because the opposite.
Because you were given the opposite length and you're trying to find the adjacent length. So tangent of 4.8 degrees equals 1.2 over x. Would you all please take a moment to solve this equation? We've done a few like this already. You're going to get a decimal approximation for tangent of 4.8 degrees. I would think of that as being whatever that decimal is over 1, and then I would cross multiply. So they're saying tangent of 4.8 degrees equals 1.2 over the length of BC. I'm calling it x. And when you get your answer, what is tangent of 4.8 degrees? 0.0843? 39. Okay, I'll leave it like that. Equals 1.2 over x. Again, I said think of this as 0.0839 over 1. Now when you cross multiply and solve, you're ending up getting, I'm putting a dot, 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 you end up getting x equaling what? 14.29? What? 14.45? Okay, so 14.45, something like that. And what units are we talking about? So that means that we really need to start building this ramp over 14 feet away from the door. Does that make sense? Okay, and let's see if that's the answer that, okay, yeah, about 14.29, 14.45, something like that. Okay. All right, I will stop here and